Okay, in this video, we're going to look briefly at electric current, potential difference, resistance, and Ohm's law. So take proper attention, listen carefully, because this is going to be a foundation for most of the things that you would learn in electricity. So let's get into it. The first thing we have here is the electric current. So what is electric current? Electric current is simply the rate of flow of charges. Electric current is the rate of flow of charges. It can also be referred to as the charge that flows per unit time. Whenever we talk about rate, we're simply referring to time, right? So here we also refer to electric current as the charge that flows per unit time. So in other words, I is equal to Q all over T. I is equal to Q all over T, where I is the current, the electric current, Q is the charge, and T is what? Time. So current is equal to charge all over time. So if you are asked, what is electric current? Electric current is the rate of flow of charges, charge all over time. Like I said, whenever you hear the word rate, it's simply referring to what? Time. You can also define electric current as the charge that flows per unit time. So electric current I is equal to Q all over T, charge all over time. The charge that flows per unit time. So electric current is measured in ampere. It is measured in ampere. That is the unit for measuring electric current. And electric current is a fundamental quantity. It's a fundamental quantity. So the unit for measurement is what? Ampere. Then the instrument used in measuring electric current is the ammeter. We can also use a galvanometer, also called a milliammeter, and this is used in measuring small currents. So the instrument we use in measuring electric current is the ammeter. We can use a galvanometer, also known as milliammeter, and this instrument is used for measuring small current. Ammeter can be used in measuring what? Large current. So having known that, let's look at this calculation question. A 20 microcoulomb charge flows through a conductor in 10 nanoseconds. Determine the current flowing through the circuit. A 20 microcoulomb charge flows through a conductor in 10 nanoseconds. Determine the current flowing through the circuit. So let's put our solution here. The first thing I want to do is to bring out the parameters. So if I read again, a 20 microcoulomb charge, what does that tell you? It tells you charge, which is Q. So Q is equal to 20 microcoulomb. So electric current is measured in ampere, right? In short, it is A. Electric charge is measured in coulomb, and the short form of it is what? C. Time is measured in what? Seconds. And the short form for it is what? S. You get? So a 20 microcoulomb charge, so this is Q, which is the quantity of electricity which is charged, is equal to 20 microcoulomb, flows through a conductor in 10 nanoseconds. So that tells you time, Abi. So the time T is equal to what? 10 nanoseconds. Determine the electric current through the circuit. Determine the electric current I through what? The circuit. So what we're looking for is the electric current. So what's the relationship between Q, T, and I? The relationship between Q, T, and I is equal to Q all over T. Current is equal to charge all over time. So it's very important that we know this, that in mathematics, micro in number means 10 raised to power minus 6. This is micro, and this is the symbol for it. Milli, the symbol for it is small letter m, and the value for it is 10 raised to power minus what? 3. Then we have nano. The symbol for it is small letter n, and the value for it is 10 raised to power minus 9. So these three things, you must take note of it all the time. Micro, this is the symbol for it, and the value is what? 10 raised to power minus 6. Milli, this is the symbol for it, small letter m, and the value is 10 raised to power minus 3. Nano, the symbol for it is small letter n, and the value for it is 10 raised to power what? Minus 9. So the charge is 20 microcoulomb. So that means that the charge is 20 times 10 raised to power what? Minus 6, because micro in number is 10 raised to power what? Minus 6 coulomb. Then nano means 10 raised to power minus 9 numbers. So my 10 nanoseconds is equal to 10 times 10 raised to power what? Minus 9. 10 raised to power minus 9 is the nano, right? Nanoseconds. So if I put in my values here, this will be equal to, my Q is 20 times 10 raised to power minus 6 over my T is 10 times 10 raised to power minus what? 9. So this 0 will cancel at the 0. So 2 divided by 1 is equal to 2 times 10 raised to power, this minus 6 that we have here. So when this 10 raised to power minus 9 goes up, it becomes plus. So this minus, as it goes up, it becomes plus. So this is plus what? 9. So this will be equal to 2 times 10 raised to power what? 10 raised to power 3. Minus 6 plus 9 is equal to what? 3. So this is equal to 2 times 10 raised to power 3 is equal to 2000 ampere. So my current I is equal to 2000 ampere. Remember, current is measured in what? In ampere. So this is my answer to this question. So this is very easy. The catch here is that just know that electric current is the rate of flow of charges, and the formula is I is equal to Q all over T. Current is measured in ampere, charge is measured in coulomb, time is measured in seconds, and the instrument for measuring current is what? Ammeter. Current is measured in what? Ampere. The instrument for it is ammeter, or we can also use a galvanometer, also known as a milliammeter, and this is used for measuring small current. So let's dash to potential difference. So what is potential difference? Potential difference is the amount of work done in moving a unit positive charge from a point to another, mostly from a point of lower potential to a point of higher potential. So what that means is that if, for instance, this is point A and then this is point B, the work done, the amount of work done in moving a unit positive charge, this is a positive charge, right? The amount of work done in moving this unit positive charge from this point to point B is what is known as potential difference. So potential difference is the work done in moving a unit positive charge from one point to another, mostly from a point of lower potential to a point of higher potential. So here we have a lower potential to a point of high potential. So that's what potential difference is all about. So potential difference, it is denoted by PD. PD means potential difference, and it is measured in volts. It's measured in volts, voltage. The short form is volts. So this is voltage. It is measured in voltage. but the short form is volt, with the aid of a voltmeter. So the instrument used in measuring potential difference is what? The voltmeter. So mathematically, V, which is the potential difference, is equal to work done over the quantity of what? Electricity, or the charge. So again, potential difference is the work done in moving a unit positive charge. So it is the work done in moving a unit positive charge from one point to another, usually from a point of lower potential to a point of higher potential. So my potential difference V is equal to work done all over charge. So V is the potential difference, Q is the charge, and W is the work done, right? So you must know this. Learn the definition of potential difference and also know the formula. This is very important. Then, having known that, let's look at this question. A 50 microcoulomb charge flows through a conductor. A 50 microcoulomb charge flows through a conductor. What does that tell you? It tells you that charge Q is equal to what? 50 microcoulomb. And like I said, micro in mass, in numbers, is equal to 10 raised to the power what? Minus 6, right? So that would be 50 times 10 raised to the power of minus 6 coulomb. So a 50 microcoulomb charge flows through a conductor, full stop, if the potential difference between its end is 20 millivolts. So the potential difference V is equal to what? 20 millivolts. And like I said before, micro, the number is 10 raised to the power minus 6. Milli is what? 10 raised to the power minus 3. And nano is what? 10 raised to the power minus 9. So what we have here is 20 millivolts. So that will be equal to 20 times 10 raised to the power of minus 3 what? Volts. So find the work done by the charge. So we're looking for the work done by the charge. So we have these three parameters. We have Q, we have V, and we have W. What is the relationship between Q, V, and W? So we know that potential difference V is equal to what? Work done over charge. Work done over charge. So what we're looking for is our work done, right? So let's make this work done the subject of the formula. So this is like V all over 1. When we cross multiply, W times 1 will give us W is equal to what? V times Q will give us what? QV. So my work done will be equal to, what is my Q? My Q is 50 times 10 raised to the power minus 6, right? So that's 50 times 10 raised to the power of minus 6 times, what is my V? My V is 20 times 10 raised to the power of minus 3. 20 times 10 raised to the power of what? Minus 3. So what would that be? So this will be equal to 50 times 20 is what? 50 times 20. So let me bring out my calculator. 50 times 20, that's this 50 times this 20, that will be equal to 50 times 20, that will be equal to 1000 times, I have this index number, 10 raised to the power of minus 6 times 10 raised to the power of what? Minus 3, right? So this will now be equal to, 1000. 1000 in index form is 10 raised to the power of 3, right? So my 1000 in index form is 10 raised to the power of what? 3 times 10 raised to the power of minus 6 times 10 raised to the power of minus what? 3, which is what I have here. So this will be equal to 10. Since all the root numbers are the same, I'll take one of them and then add the powers. So this will be 3 plus open bracket minus 6 plus open bracket minus what? 3. This is the multiplication law of indices. So this will be equal to 10 raised to the power of 3 plus times minus will give you minus 6 plus times minus will give you minus 3. So 3 minus 6 minus 3 is what? So I'll bring out my calculator and press that. 3 minus 6 minus 3 is equal to minus 6, right? So this will be 10 raised to the power of what? Minus 6 joules. This is my answer. Because work done is measured in what? In joules. So my work done can also be equal to 1 microjoule. Remember, micro means what? 10 raised to the power minus 6, right? So if my work done is 10 raised to the power minus 6 joule, that can also be equal to what? 1 microjoules. So let's go back to this point. So potential difference is measured in what? In volts. Very important. Charge is measured in what? In coulomb. In coulomb. Then work done is measured in what? In joules. This is very important, right? Okay. So having known this, the next thing that we're going to look at is resistance. Resistance. So we'll continue with resistance in the next video. Thank you.